Welcome back to our SQL learning session. Today, we'll be talking about analytical functions from Database for Developers. Here, in this model, we have 12 sections. First section is introduction. In introduction, let me dig into introduction right now. The aggregate and analytical function both enable you to do a calculation over many rows. The answer aggregate function squash the output into one row per group. Following counts total rows in a total table. For example, the following counts total rows in a table. It runs one row. Now, we can also add over clause to convert an analytic function. This preserves the input rows, but we also get the output rows that you get from the group count, group by, or from count or group by. Here, what we are doing is we are selecting from count, we are selecting from bricks, and taking the domain of whole domain is all the rows of the table, and we are counting total number of rows and displaying the total number of rows of a table for each row. This allows you to see the values from all other columns which you can't group, which you can't using group by. Now if I run this, I will see the other columns of the table, including the total number of rows of the table. Partition by. The group by clause splits a row into groups of the same value. For example, the following get the number of rows and total weight for each color. You can carve up the input into analytical functions like this with partition by clause. The following returns a total weight and count of rows in each color. It includes all the rows. Here, we are getting data from bricks and we are displaying all the columns. And also we are appending two extra columns where we are counting rows per group of the color, per color, and displaying it for that particular color group. And also, we are also summing the weight for each color group and displaying the weight for each color group. Here, you see bricks per color. Blue has blue color has two brick associated with it. While for this particular weight, one it has three bricks associated with it. That's why we have three here. Now, let's do an example. In this example, we need to complete the query to return the count and average weight of bricks for each shape. This is a partially filled query. And when you fill this out, can you take a moment to see what needs to be done, what needs to be filled out to get the result we want? Let me show you. Here, we need to complete the query to return the count and average of the bricks for each shape. Therefore, since we are doing calculation for each shape, then we need to partition by the shape. Median weight, average weight for each by shape. Now, Order by. Order by clause enables you to compute running totals. For example, following sorts a row by brick ID, then shows the total number of rows and sum of the weights for rows with brick ID less than or equal to current row. Here, we are getting data from bricks and we are counting the total number of rows by brick ID. And also we are summing the weight. It's a running total of the weight by brick ID. It's a running total. 1, 2, 3, 4, 5, 6. Running weight. 1, 2, 3, 4. 1 plus 2, 4. 4 plus 2 is 6. And that's how it goes. Now let's do an exercise. Here we're going to come to the query to get running average weight ordered by brick ID. This is what we need to do. Can you take a moment to see what needs to be done to get the result we want? Let me show you. Yeah, we're going to come to the query to get a running average weight ordered by the brick ID. This is ordered by the brick ID, but we need to get running average weight. Running average weight. And this needs to be ordered by brick ID as well. We need to get a running average weight ordered by the brick ID. Therefore, we need to average this, we need to order by brick ID as well. Then if we run this, we should get result what we need. And this is exactly what we need. Partition by and order by. You can combine partition by and order by clause to get running totals within a group. For example, the following splits a row by color. It then gets running count and weights of row for each color, sorted by brick ID. Here, it is getting data from bricks, counting the rows, each partition ordered by brick ID, and it's a running total for each partition, and also it's a running weight for each partition of the color ordered by the brick ID. When you use order by, database adds a default windowing clause of range between unbounded preceding and current row. This means in all rows with a value less than or equal to the current row. This can lead to function including values from rows after current. When there are same values or multiple same values within the table. For example, there are several rows with the same weight. So when you sort by this, all rows with the same weight have same running count and weight. Here's an example. You are ordering by weight and there are several items with the same weight. This is a weight. There are three weights and those all three have a running total as same. Similarly, the running weight is also same because of all these three items have the same weight. Usually this isn't what we want. Normally, running totals and should only include the values from previous rows in a dataset. To do this, you must specify a windowing clause, row between unbounded preceding and a current row. Here's the example. Here we added a clause, rows between unbounded preceding and current row, and also rows between unbounded preceding row for both of this expression. Now if we run this, it should give the result we want. Here, running total is 1 for first row, and for second row is 2, 3, 4, 5, 6, and so on. But for running weight, it's going to be 2, 3, all the 3 is 3 here, plus 2, 3 plus 5, 1, 2, 3, 4, 5, 5 here, 7, 1, 2, 3, 4, 5, 6, 7. So that's how it goes. Note, this makes your result more non-deterministic. This row of the same weight could have running totals in different order each time you run a query. To fix this, add columns to order by until you get a set of values in sort appears only once in your result. This makes your result deterministic. Since we are just using the only one column for sorting, it can go on deterministic. It can reverse itself sometime. It can come in different order sometime. To make sure that we are getting the same sequence every time, we need to add a column here to make it more deterministic. Brick ID, and also this one. They should make the row presentation more deterministic. Sliding window, as well as running tables so far, running totals so far, you can change the windowing clause to be a subset of previous rows. Following following shows total weight of count plus previous rows, current row, all the rows in the same weight as the current plus all the rows in the weight one less than current row. Here, what we are doing is we are taking rows from bricks, ordering by brick weight and brick ID. That's the first thing. And secondly, we are summing the weight for all the rows from current row to the one preceding, just one before that. And we are ordering by the weight. Secondly, we are also summing the weight over range of values of weight from current, the value of the current row, or the weight to the one next previous value, and ordering by weight, and then doing as a running weight, running value weight, or running row weight, and naming those two columns as running value, running row weight. Now you see here in this column, running row weight, it is taking the current row and adding one before to get two here. But if you look at this one, you are getting three because this one has next row also has a one. So you are adding all these three to the total weight. Now you are getting three here. Similarly, current row has a 2 and you are adding one previous to it. So 4, 7. That's why you get it like this. You can also change current row to rows value after current. To do this, to do this by specifying number following. For example, this query computes sliding weight including rows or values either side of the current row. Let's run this and see what we get. Here we are getting data from bricks. We're summing the weight, and we're targeting the rows one before and one after the current row, and ordering by weight. Similarly, we are also summing the weight over range of current weight value and one previous value and next value, and we are doing average of that, and we are doing some of that, and then displaying the sliding window values. Here we are taking this row. For this row, the previously there is no row, so therefore it's going to be 0, and for next it's going to be 1, so therefore we are displaying 2 here. And for this one, next one following, that means we are taking this one, all the values one have, and next value is 2, so we'll be adding all these three values for this set of values to get the value we need. The sliding window, value window, one, this can be 3 plus 4 is 7. That's how it's going here. You can also offset the window, so it's the current row. You can do this either side of the current row. For example, following query has two counts. First shows the number of rows with a weight 1 or 2 less than current row. Second count those weights greater than current row. So if the current weight is 2, the first count includes the row weight 0 or 1, second row with weight 3 or 4. Here's the example. It is taking the row from the weight and is counting the rows on the value of weight between two preceding values and one preceding value. Similarly, it is counting the rows in a range between one next value and next two values. These two preceding, one preceding, is in this format: min, comma, max. Similarly, you can also say this is under this format. So if you run this, you should get this result. Is looking for count over weight. It is looking at the range preceding two preceding value and one preceding value. That is, two preceding value is this is the first value. So there's no two preceding value. There's no one preceding value. That's why we get 0 here. And but for this one following and two following, one following is this and two following is this. That's why we get 3. Counting the number of rows here. We are not summing anything. We're counting. So 1, 2, and 3. That's how we get 3 here. And similarly, how about this one? 2 preceding, 1 preceding. How about for this row? What is 2 preceding, 1 preceding? For 3, 2 preceding is this and 1 preceding is this. Now if we sum these two, 1, 2, 3, 4, and 5, and thus we get 5 here. But for this one, it is 0 because there is nothing after. Since the last row is going to be 0. Now let's do an example where we need to complete the window class return minimum color of 2 rows before, no, but not including the current row, and counting the number of rows with the same weight as the current row and one value following. Here's a partially filled query. Can you look at this query and tell me what needs to be done to get the result we need? Let me show you. In this one, we need a minimum color of 2 rows before the current row, but not including current row. 2 rows before current row. That's the rows between two preceding and one preceding. They should give the minimum value of 2 rows before the current row. Second one, color, count of rows with the same weight as the current and one value following. So, but this will be range current row and one following. And this should give the result we need. Let's run this. Missing parenthesis. Why is saying that? Let's figure it out. Let's cut this. Now we know the mistake is here. Range between, it's going to be between current row. We miss a keyword. Between current row and a phone following. This should get the result we need. Section 10. Filter and analytic function. Often you want to filter rows using the result of aggregate. For example, to find all the colors you have, two or more bricks of. You can do this with group by using the having clause. For using group by, you can do but using having clause to filter the aggregates. This is what we are filtering aggregate for. Let's run this. Therefore, we have count. Let's put one count here so we can see what's really going on. But you can see the other columns. One way to include this is to partition by calc using analytical function and using partition keyword. But the dataset process analytic function after a where clause. So you can use this in a where. The following raises an error. You cannot use the analytic function where clause. That's a no-no. To resolve this, you must use analytic function as subquery, then filter it in outer query. Now we are using subquery, a subquery to process intermediate result, which is created by analytical function. Therefore, we are doing select from, and this will give the intermediate result, and we are filtering on top of that. Let me run this. It should give us count of the color rows per color group. For blue is 2, and we are using as that as a source table and filtering on top of that where count color is greater or equal to 2. Now, section 11. Let's try this. This is an exercise where we need to complete the query to find rows where total weight for the shape and running weight by bricks are both greater than 4. Can you take a look at this query and see what needs to be done to get the result we need? Let me show you. We need to complete query to find a rows where total weight for the shape are greater than 4. Therefore, we need to add a where clause here where total weight is greater than 4 and running weight ID is greater than 4. What's remaining here is we need to complete this sum. We are summing by weight, total weight for each shape. Therefore, all we need is partition by shape, running weight by brick ID. Therefore, we get order by brick ID here to get the running weight by brick ID. And this should give the result what we need. Let's see. And this is exactly what we want. Moving on to section 12, more analytic function. You can add over clause to aggregate functions to make them analytic, but there are many functions which need over clause. Here's an overview of common analytic functions. Row numbering. Analytic function rank, dense rank, row number, all return increasing counter starting at 1. Rank. Rows with the same value in order by have the same rank. Next row after a tie have n, where n is a position data set. Dense rank. Rows with the same value is in order by the same rank, but there are no gaps within the rank. Row number. Each row have a new value. Here's an example. This is a sequence number for each brick, and for rank, whenever there is a gap, this is a row number. This is a row number, so it's exactly the position in the data set. Second is rank. Whenever there's a two tie, it gives a one, and when it encounters a new weight, it gives four. The position of data set within the data set. But in dense rank, what happens is that you are giving same value for all the same value, same rank for all same value. But when it encounters a new weight, it gets two. There's no gap in between. Previous and next values. Lag and lead enable you to get values from rows backward and forward in your result. Here. In this, we are using lag shape to give the one previous value and lead the next value of next row. And we are ordering by brick ID here. Here, the lag is empty because there's no, this is a first row and there's no previous value for shape. And the next value for shape is pyramid. So that's why it is displaying pyramid here. Lead. First and last values. You can get a first or last value in order set with the first and last value. Let me run this example. Let me run this. In this, we are ordering by brick ID, and first value is 1, and it's 1 for all the column for first weight by ID. But for last, it is giving 2. It is same as what we have in a weight. Why is that? Because order by has a default windowing clause where it says that give me the range of all previous values up to current value. Therefore, that's why it is giving the same value as current value. All previous values to the current value. And that's why it's giving like that. In the end, let me quickly summarize what we learned today. We learned about analytical functions. We learned about partitioning using over, and we also learned about order by in partitioning in over. And we will learn about how to combine partition by order by. In addition to that, we will learn about windowing. How can window the moving window as we move through the data. We will talk about sliding windows, and we will talk about how we can filter analytic function, where we can use a subquery to filter analytic function. So that's all for today. I will see you next learning session. Thank you so much.